Howdy. Awesome. Well, it's good to be here. I know we did a press conference the other day. We'll just go straight into questions. I've got about a half an hour, so let's start with these little. You guys have questions? You got a microphone. Tell me your name. Andrew. And what's your name? Very nice to meet you, Andrew and Evangelina. So, and do you have any questions? Amazing questions. He says if you, how old are you, buddy? 8. So I've got a 7-year-old. His question was, if you want us to be inspired, why do you put such an age limit on going to the moon? Is that your question? Just in general. Yeah. Well, maybe one day, with permission of your parents, young folks and maybe entire families will be able to go into space. Maybe one day. That would be a lot of fun. We're not there yet, though. There's still a lot of risk involved in this, and we want to make sure that we're keeping young folks safe. So, but that's a wonderful question, and of course, we want you to be inspired. We want you to want to go to space, and but maybe you'll have to wait until you're 18 or something. All right, we'll do some questions. Wow. I'll start with Marcia. Is there a mic? I'll repeat your question.
We're sending humans to Mars, but what robotic missions must be done before you send the humans? Must there be a Mars sample return mission? Must there be a communications network before we send humans?
So the question is, what robotic missions must be done before we send humans to Mars? Mars is the key here. So, remember what we're doing at the moon. We are building an architecture at the moon that is as much as possible replicable at Mars. Now, depending on the Mars mission that we do, we may or may not have to be on the surface of Mars for up to 2 years. For example, if we have nuclear propulsion, nuclear thermal propulsion, that gives us opportunities to maybe not have to be on Mars for up to 2 years. If we are able to go sufficiently fast where we could be at Mars in the year 2033 or 2035, which is in the realm of what is possible if we get the budgets, but I'm not saying we're going to get the budgets, I'm just saying it's technologically possible if the budgets were to materialize. We could go to Mars and use a gravity assist from Venus, for example, as a flyby in order to go faster. So these are the things that we have to look at the trades and then make decisions about. Would we spend, say, 30 days on Mars, or are we going to have to spend up to 2 years on Mars? And looking at those different trades would determine what robotic missions need to be done ahead of time, what technologies need to be developed, and how much time are we going to have to spend on Mars for that first mission. So I know this isn't the answer you're looking for, but the answer is it depends. It depends on how long we're going to have humans on Mars. But here's what we know. We're going with the Mars 2020 rover, and the Mars 2020 rover is going to have MOXIE on board, and that's going to enable us to figure out, can we use the carbon dioxide of the Martian atmosphere ultimately to create oxygen. We also know that we're going to have a Mars helicopter on the Mars 2020 rover. We do want to do a Mars sample return. The reason that's important is because it will help us make decisions as to what we want to do when we're on Mars. It increases or decreases the probability that we might find life, for example. And so all of these things we need to understand better. And I think the answer is it's all going to depend. But between now and that day, we've got some time to learn what we need to learn. Yeah. All right, we'll start here, and then we'll go left to right. Actually, I'll mix it up. Yeah.
Some great announcements about Artemis and international collaboration. We've got Italy and also Japan on board now.
Yes.
Any other announcements? And specifically, is India made any suggestions to making participate in Artemis?
A couple of things. Yesterday, 2 days ago, We did a multilateral regarding Artemis with all of the nations that were interested in coming, and we had 26 nations participate in that multilateral. We're trying to understand what different countries can bring to the table to help us achieve the outcome of not just sending the next man and the first woman to the moon, but how do we create sustainable operations at the moon with an international coalition of partners. And what we have found is that there is lots of interest. And I can tell you, there is no question there is interest from India. At this point, we don't know who's going to be doing what, but certainly India is one of many countries that is interested in participating, I think, in this really historic development. So,
Thank you.
Good question. We'll go here and then here.
Clearly, other nations want to land their own people on the moon. Could it be the second landing, for instance? And how are you going to choose between the Europeans and the Japanese, who are clearly candidates?
That's a great question. He said there are other nations that want to land on the moon with their own astronauts, and could the second mission include those international partners? I don't know, but here's what I do know. The United States of America has, in Space Policy Directive 1, that this time when we go to the moon, we go with international partners. And when we look at what the contributions of our international partners are to this operation, you can imagine there are going to be a lot of countries that step up to the plate at a level that would say, okay, that warrants having an astronaut on the surface of the moon, and we want that. We want them to have their astronauts on the moon. The goal is to have many different nations living and working on the moon at the same time with a coalition. That's the goal. So is it the second landing? I don't know. I guess it probably depends what we learn on the first landing, but certainly there's plenty of opportunity, and when this is sustainable, there's not going to be a shortage of opportunities for astronauts in the future. Remember, the gateway itself, and this is also important, the gateway itself is going to be in orbit around the moon. It's a 15-year life cycle is what we're building towards. What that means is that other countries, if you want to have a lander that you want to take humans to the surface of the moon, you can build it, because the gateway is open architecture. And the way we do docking, and the way we do environmental control and life support systems and avionics and data and communications, all of that is going to be available to the public. And small countries, large countries, private companies, they can build their own landers and they can send people to the moon for reasons that are not necessarily NASA's reasons for going to the moon. So the answer is, I think there's lots of opportunity within the Artemis program itself, but remember, the Artemis program includes the gateway, which is an open architecture, which means there's going to be opportunities that extend beyond even the NASA Artemis option, if that makes sense. So remember what the goal is. The goal here is to be as inclusive as possible with international partners and commercial partners, and the gateway is the enabler to achieve that. We'll go here.
I'm Alan Boyle with eChoir.
Yeah, Alan.
Jim, you mentioned that there are some interesting things being brought to the table, and that there might be some things that you really want in the future. Can you give some examples of some of the more interesting opportunities that you're looking at?
You're talking about for Artemis specifically, or
For Artemis and for international partners.
international partners? So look, there's no shortage. Like right now, NASA has over 700 agreements, international agreements with countries all over the world. It's over 700 active right now. And when you think about the fact that on top of our active agreements, we also have 15 nations that have been operating the International Space Station now for what we're entering our 20th year. We have had experiments from 103 different nations. We've had astronauts from 19 different nations. So this truly has been a demonstration of not just technological capability, but diplomatic capability, not just for the United States, but for countries all over the world. Very positive in nature. I would also say that when we go to the moon, because it's open architecture, there's going to be a lot more opportunities. So, what are those opportunities? And a lot of people have heard me talk about a mission we call DAPPER, which I'm very excited about. It's going to be an astrophysics mission in orbit around the moon, and from the far side of the moon, where it's very quiet from an electromagnetic spectrum perspective, we're going to be able to see not just a cosmic dawn, the first light in the universe after the Big Bang, but we're going to be able to see even before cosmic dawn into what we call the dark ages. And so we're not just looking out into space, we're looking in fact back into time, which is, I know it blows my mind, I'm sure it blows yours. So when we think about that, that mission under the Science Mission Directorate of NASA would be a $500 million mission. But if we have a gateway in orbit around the moon with a comms architecture in orbit around the moon with high throughput and large aperture antenna, all of a sudden the architecture that we built for sustainable human presence on the moon becomes a capability to deliver a whole lot more science for a whole lot less money. So instead of building a half billion dollar astrophysics satellite in orbit around the moon, now we can build a $90 million astrophysics satellite in orbit around the moon and integrate it into a networked architecture of satellite communications, a node of which, of course, would be the gateway. So all of this conspires to say not only are we breaking down the stovepipes that have historically existed between science and human exploration, now we're saying human exploration is enabling science, and more science than ever before. The stovepipes need to go away. We need to start looking at it holistically and saying, if you're an international partner, and I've talked to a lot of international partners here, they have their own astrophysics ideas, looking out into space in different parts of the spectrum. We love that. Here's what we know about science. Everybody shares it. NASA shares it. We share it with the world for free. And any other countries out there that want to do their own science, they share it with us for free. And all of a sudden we get a whole lot more knowledge and information at a whole lot less price. And that's because we're going to the moon with an architecture that's sustainable for the long term. But remember also what we're doing, we're building with a mission to go to Mars. And again, there's going to be a whole lot more science there. So when we talk about heliophysics, the study of the sun, we can do that from the vicinity of the moon. In fact, the lunar regolith itself is a repository of data and information from the early sun. Because the moon doesn't have an active geology, it doesn't have an active atmosphere, it doesn't have an active hydrosphere. All of this stuff conspires to say we can learn a whole lot about the sun. The subatomic charged particles that have been coming out of the sun and hitting the moon for billions of years, they are today right where they were billions of years ago. So we can get a lot of information about our early solar system. But it's astrophysics, it's planetary science, it's earth science. Remember, most scientists arguably would say that the moon was at one time a part of the Earth. And so we can learn about the Earth by studying the moon, the history of the Earth. We can do astrophysics from the moon, and in fact, we can do planetary science, use the moon to figure out how do we go to other planets. So there is so much opportunity, and because it's open architecture, there's opportunities for international partners and commercial partners, things that I'm not even thinking about right now, things that none of us have thought of yet. So we're opening it up so we can go further and do more in space than ever before. I'm going to go here. David.
David Todd of Serenade Space Building. Do you think that the EUS upper stage is absolutely essential for the future plan?
The question was what we call the EUS, the Exploration Upper Stage, which would be developed for the SLS rocket, and is it essential for the program? I'll answer it this way. So remember what we're trying to do. We're trying to get to the moon and we're trying to go sustainably. So if you have an interim, what we call the ICPS, the interim cryogenic propulsion stage on top of an SLS, that changes how we get to the moon because it does not have the throw weight of an exploration upper stage. What that means is we have to get as much energy out of the core stage of the SLS as we can possibly get. When you get that much energy, what that puts you into is it puts you into a very elliptical orbit around the Earth, very elliptical. And if you want to go to the moon, and you're in an elliptical orbit around the Earth, because you got as much energy out of the core stage of the SLS, what that means is you have to fire the European service module at the exact right time when you're at perigee and you have the maximum kinetic velocity. Now you have to fire that European service module engine at that moment when you're at perigee in that highly elliptical orbit And when you fire that, the moon has to be in the exact right spot. And what that does is it puts you in a position where you will actually intercept the moon. As the moon comes around, you'll go in front of it, and the moon's gravity will capture you. And of course, there'll be some extra energy that you have to burn to make all of that happen. But the bottom line is those opportunities where the moon is in the exact right spot, and you're at perigee at the exact right time, and you fire that exploration, or I should say that European service module to get to the moon, those opportunities happen 4 or 5 times every month. So all of a sudden there's a big risk that we're taking that we otherwise wouldn't have to take. If we roll out to the launch pad and then and there's a delay for some reason, maybe it's weather, maybe it's some kind of technical challenge, and we're not ready to go, guess what? Now we have to roll back out. And so you didn't just miss the launch window, because now you're going to have to recharge cryogenics and do all of those other things. We're talking about missing maybe the next launch window. So there's a risk here, and the risk is we're not talking about a risk to humans necessarily, although there is a part of that is of concern. But there's a risk here to cost and schedule and sustainability. So the interim cryogenic propulsion stage can get the job done, but it is not optimum, and in my view, it would be in the interest of the United States, it'd be in the interest of a sustainable presence to go to the moon, to have an exploration upper stage that instead of having to go into that highly elliptical orbit, you can get into a circular orbit, and you can make your run on the moon at any point, at any time of the month.
You're fully committed to the US.
Well, look, I am committed to what gets appropriated by the House and the Senate. I'm also committed to the budget request. When there's all kinds of competitions for resources, and our government isn't any different than anybody else's government. We do not have endless resources. But I am telling you what the realities are, and these are truths that we cannot avoid. And the truth is that we have more opportunity to reduce risk and improve capability and improve reliability if we have the exploration upper stage. All right, we'll go here.
As a former legislator, do you think that the Trump impeachment questions and the issues now kind of facing Congress are going to make it harder for this program to be funded?
So the question was about impeachment, and is that going to make it harder for the program to get funded? The answer is I honestly don't know. I will tell you this, and I've been working really hard, and I know you know this. What we are trying to achieve here is not partisan in any way, shape, or form. We have strong bipartisan support. I've been traveling the country meeting with senators and House members on both sides of the aisle. What we're trying to achieve here is multi-generational in nature, not just spanning administrations, but spanning generations. And it's good for the United States of America. It's good for diplomacy. And when we achieve this, it's going to inspire generation after generation after, just like we saw, July 20th when we celebrated the Apollo 11 moon landing. 500,000 people on the National Mall all at the same time celebrating this historic human achievement. I've seen 500,000 people on the mall before. They're never happy. In this particular case, they were all happy celebrating something. That's what we're trying to create here. So I will tell you, we have strong bipartisan support, and I don't want to get bogged down in these other kind of questions that I'm not saying it's not an appropriate question, but I don't want to get NASA bogged down into that. I don't pay any attention to it. My job is singular. I represent NASA, and I'm trying to make sure that we have a sustainable long-term exploration and science program that all of America can be proud of. And in fact, all of our international partners can be proud of as well. We'll go over here.
Hi Jim, thank you, and you're so gracious to come and talk to us. Can you tell us a little bit more about the role of universities?
Great.
In the role?
Yeah, universities are absolutely critical. So we have an entire mission directorate called the Space Technology Mission Directorate, and it is focused on what we call low technology readiness level capabilities. What do we need to start investing in today that could benefit us 10 years, 15 years, 20 years from now? And that's where universities are really strong, technology development, because of the great minds that are at universities. And so we use the Space Technology Mission Directorate to look at what are we going to need 15 years from now, and where are the brightest minds and the most capable academics that can help us achieve the early stage development of those technologies that we can then take advantage of in the future. Universities are very good at that activity, and we invest in that. I would also say a lot of the data that we get back, whether it's the data from heliophysics, whether it's study of the sun, planetary science, astrophysics, that data generally goes back to universities, and it gets shared with the world. Earth science data, and all of that data gets looked at and analyzed by the brightest minds, not just in the United States, but by the brightest minds all around the world, and that data is shared with the world for free. And of course, other countries share their data with us for free.
Are there any specific projects relating to Artemis and universities?
Are there any specific projects related to Artemis and universities? Yes, there no doubt are. I'd have to get back to you on that just to say specifically which ones are being done. I know this. Draper Labs, okay, Draper. There, I said it. You got it. But I would also say, when we think about the capabilities for the moon, Arizona State University, of course, operates an instrument on the Lunar Reconnaissance Orbiter. So they own and operate the instrument, or I should say they operate the instrument on behalf of NASA, and all the data goes there, and they use that data, and they share that data with the world, and of course NASA benefits from it, and their students benefit from it. But that's one example of the moon specifically, but Arizona State, the Jet Propulsion Laboratory.
We want USC to be a part of it.
Okay, got it. All right, we got to roll. All right, we'll go here.
Progress on flying additional seats in the first stop that we're talking about now. Have you been talking to any experts on
Yeah, so the question is about getting the waiver necessary if we need to buy additional Soyuz seats based on the commercial crew development. At this point, we have not made those negotiations yet. It is highly likely that we will enter into a negotiation, make the request from Roscosmos for at least one additional Soyuz seat, maybe additional after that. But here's what we're focused on right now, and we're having some very good success. We need commercial crew to be successful. We want the relationship between the United States, or I should say NASA, and Roscosmos to continue to be strong. So even when we are successful with commercial crew, we want to make sure that we have a permanent American presence on the ISS. Roscosmos wants to make sure they have a permanent presence on the ISS, which means we're going to need to launch on Soyuz rockets anyway, and they will need to launch on commercial crew rockets, and that's the partnership that we believe in, that we want to achieve. But is it necessary for us to buy another seat? Likely, and no, we haven't yet begun those negotiations. Have we requested the waivers necessary to do those negotiations? I'm not sure where we are on that at this point, but I can get back to you.
Last question.
Okay.
Last question.
Well, let's do two more. Two more questions. Because some of you, and I apologize. I'll go right here to this lady with the backpack.
I'm going to get a little bit probably out of the box here with this. At the plenary session this morning, we were talking about if we're going there, we have to be able to sustain ourselves there. And so in a discussion about sustainability, they were talking about using human waste, methane gas, turned into fuel while we're up there. Now, putting a human factor with it, man's best friend, Laika, sustained orbit and thrived when returned to Earth. So I'm thinking if you get the dogs up there with them, you've got the companionship, and in DC we know you need a dog.
That is way out of the box.
But yeah, it is. But if you're talking about using waste to build the methane gas and that.
So here, let me tell you what I think is the best option.
Okay.
Number one, we know that there's hundreds of millions of tons of water ice on the south pole of the moon. It is there. Water ice is hydrogen and oxygen, and of course hydrogen is the same rocket fuel that powered the space shuttles. So we need energy. Let's figure out how to use the hydrogen. The other way to get energy, of course, is solar. And when we talk about the poles of the moon where there are peaks of eternal light, there's lots of opportunity to use solar energy as well. And then, of course, there's battery power, and beyond all that, maybe even nuclear power that we could use for energy on the moon. I'm talking about small 1 kilowatt nuclear reactors that would enable us to sustain long periods of time on the surface of the moon. So there's lots of energy opportunities. I don't think necessarily that waste is the most optimum way to go about doing it.
But it would give the dogs a chance to go up there so people would have a
Okay,
pet.
got it. All right.
So no dogs on this.
I've got a young lady here, and then I'm going to do her, and then one more. I'm sorry, Bettina, but I'm just thrilled there's so much interest here. Yes, ma'am. The question, it's Evangelina, is that right? So Evangelina, how old are you? 7 as well. She asked, have we started choosing the girls for Artemis? Because you want to be one of them, don't you? So the answer is, we have a great astronaut corps right now that has women, and they are fantastic. And I'll tell you this, they all want to be the first woman on the moon. So, one of them will be. I don't know which one it's going to be, and we're not ready to start selecting at this point, but know this, one of them will be, and maybe you two could go with them one day. So, all right, we'll go right here. Great question. The question is about entrepreneurs and startups in the Artemis program, and of course there's a lot of opportunity there. When we talk about entrepreneurs, there's big entrepreneurs, there's small entrepreneurs, but know this, what we're building at the Gateway is open architecture, and we want to go with commercial partners. So there's in fact a number of companies here, big companies, that have said they want to go to the moon, they want to go sustainably, they want to be part of Artemis. And the Gateway is available to them, and in fact we even put in the BAA, the broad agency announcement for how we're going to get to the moon, that if we can go to the moon directly and go faster, then we want to do that, but we also want to go sustainably. So they have to demonstrate sustainability even after the direct mission, which ultimately I think long term is going to require compatibility with the Gateway. All of that being said, there is no doubt a lot of opportunity for entrepreneurs. We're going to need cargo on the surface of the moon. So remember, SLS and Orion, that is a human qualified rocket the day it is ready to go. So we're gonna that's our way we're gonna get humans there as soon as possible. We got to get there within 5 years. On top of that, when we talk about aggregating a lander at the Gateway, when we talk about maybe even putting hardware on the surface of the moon, maybe science hardware like Viper, neutron spectrometer, an IR spectrometer, helping us understand the regolith, the water ice, what's there on the surface of the moon, where is it, what quantities, how is it integrated into the regolith. We're going to need those science instruments delivered to the surface of the moon before we send humans. Maybe even, again, it depends on budgets, and I'm not promising anything between now and 2024, but maybe even an inflatable habitat on the surface of the moon so that when our astronauts get there, they have a place to go and they can stay for longer periods of time. Is that in the realm of possibility? Absolutely. But know this, we're going to need, on top of SLS and Orion, we need additional capability. There's opportunities there for all kinds of commercial companies, entrepreneurs. We also have small business investment and research that NASA's involved in, where we're on-ramping small businesses all the time. In fact, right now, we have the Commercial Lunar Payload Services Program underway. We have 9 companies that have signed up with an IDIQ contract. 2 of them now have task orders to deliver to the moon in 2021. Those are small businesses that are going to be going to the moon. This is an extension of the Google Lunar X Prize that nobody won, but now NASA gets to take advantage of that. It's a very positive thing. We want to take advantage of it. We're on-ramping not only those 9 companies, but we want to on-ramp additional companies and maybe even bigger companies for larger landing opportunities, because like I said, we're going to have a lot more needs in the future for cargo on the surface of the moon. All right, I'm getting the hook, and I apologize. I just want to tell you how grateful I am that there's so many people here, that there's so much interest. Know this, we are getting strong bipartisan support here in the United States of America. And I will also tell you that we are getting amazing support from our international partners. We are going to the moon. This is our generation and it is our time. I am the first NASA administrator that was not alive when we had somebody on the moon. I have no memory of the Apollo 11 moon landing. I have no memory of the Apollo 17 moon landing. I wasn't there. We cannot allow another generation to go by without that capability. This is our generation. We love Apollo. I want to be really clear. We love Apollo. But the Apollo generation, all of our astronauts came from fighter pilot backgrounds and test pilot backgrounds, and there were no opportunities for women in those days. Today we have this very diverse, highly qualified astronaut corps that includes women. We go to the moon this time sustainably. Again, the key word sustainably. One of the challenges with Apollo is that it ended. We go to the moon this time sustainably under the name of Apollo's twin sister in Greek mythology. Her name is Artemis. Artemis was the goddess of the moon, and this time we go with a very diverse, highly qualified astronaut corps that includes women. We go with international partners. We go with commercial partners. And I am so thrilled that there is so much interest in this activity. So thank you all for being here. God bless. Thank you.